off of the YouTube recordings than really participating in class. It's easier, just do it with me so you don't have to watch class all over again because it takes the same amount of time, but you know, happens. So we finished here at rule number 8, right, from last class. We're ahead of everybody else. So we did this in all the other classes earlier today, well, except for career exploration. So we finished rule number 8, which was multiplying rational numbers with the same sign. And remember, we learned same sign is kind of tricky, right? Because when we have the same sign, that means that we have two positives, right? We multiply a positive number by a positive number, we will get a positive number. And then if we multiply a negative number by a negative number, we will get a positive number. And we need to think about our adding and subtracting. When we were subtracting a negative number, we had to do the opposite, right? This is kind of like that same concept. If we were to multiply two negative numbers, we get a positive, because if we have one positive number, one negative number, that would give us a negative. And we're going to go over that today. That's our rule for part 8. But we learned about the same sign rule last time. I feel like it's kind of a trick when they say same sign rule, because the idea of same sign kind of tells you, like, if I multiply two negatives, it's going to give me a negative. But if I have a positive and a positive, it'll give me a positive. If I have a negative and a negative, it will give me a positive. And we have another same sign situation right here. See how I wrote it? The two positives at the end, we will get positives for both answers. So it's kind of like the same sign idea. What I like better is only in math will I have two negatives. Multiplying a negative by a negative will give me a positive. Right? Because in real life, if you have two negatives, it usually doesn't make a positive. But in math, it does. Okay, so there's a little bit of a review of what we did last time. We didn't have time to go over the guided practice. Usually I have you do that on your own and then we go over it. But the last little section of what we talked about last time was a little bit rushed. So we'll go ahead and we'll do the first guided practice together. And then we'll move on to rule number 9. You are Picasso. Very nice. All right. So for our guided practice, and just so you guys know, when we're doing since we're doing the Nearpod, you guys have to put your name in before you even start on the Nearpod, so you don't have to fill your name out here. That's just, if we were in class, I would say I would need your name on it, but you don't have to type that in. I've noticed a lot of you guys type your name in, which is good practice. I appreciate it, but you don't have to. All right, so guided practice for section 8. And I know section 7 was a little bit of a trick with that guided practice because it was mostly based on the information from the previous lesson, but fortunately this one stays true to section 8. All right, so find the product. Now that we are working with multiplication, we have a new buzzword. Remember last time we talked about sum, talked about difference, because those are words that go with adding and subtracting. But now that we're multiplying, we have find the product. The product means that we need to find the answer to an equation where there's multiplication. Right, so let's say here's our numbers, or multiplying, right? Here's our answer. So product just means the answer to an equation that's going to involve multiplication. Another thing I want to point out is when you multiply numbers, let's just throw in some variables, right? Variables mean letters, right? Because we know algebra. We can handle algebra. See, so let's say I have x times y. What I want to point out is this dot right here. Remember I told you guys, multiplication doesn't always have an x, especially when we are learning about algebra, because you don't want to mix up that x, that multiplication x, as a variable of x. Okay, so find the product. If I have x times y, my product would be equal to xy, right? This right here is the product. And I know that the SBEC had a couple questions that asked what is the product, especially that area question on the CAT test. Or sorry, not the CAT test, the performance test. Remember it said find the product if the area, or if one side of the golf, I think it was like the golf green was 12 feet, right? That means you're supposed to do, find the answer for the 12 feet, and then I think you're given a max of 180. But in essence, you knew that it was a multiplication problem because they used the verbiage, find the product. And it's like a nice little helpful hint as you're test taking to understand those math terms, math language, okay? So I am finding the product. I'm going to be multiplying a negative number by a negative number. And again, I have -4, parentheses, negative 3.75. If I have parentheses, I need to, do the parentheses first if I'm talking about the order of operations. In order to get rid of parentheses, I need to factor through or find the answer, right? So I need to factor through the -4. There's nothing inside the parentheses, no other math that I need to determine the answer for. So I'm just going to do -4 times negative 3.75. So according to our rule for multiplying rational numbers with the same sign, if I have a negative times a negative, I'm going to get a positive number. Okay. So I'm going to take 4. I'm going to multiply that by 3.75. Whenever I am multiplying with decimals and I don't have a calculator, I usually set it up with like this. So 4 times 5 is 20. Carry the 2. 4 times 7, 7, 14, 21, 28, plus 2, that's 30. Then I have 4 times 3, that's 12, plus 3, that is going to be 15. Then I need to add my decimal point. Since I have 2 numbers here, that means I will have 2 numbers here. So I put my decimal point there. Or you could use a calculator. All right. So my answer for -4 times -3.75 is going to be positive 15, right? Because we're multiplying our 2 negative numbers. When we have 2 negative numbers, that gives us a positive. So my answer for number 1 will be A. All right, so the next one I want you guys to answer. I'll walk through it with you, but I want help with the answer. You can answer in the chat or you can unmute yourself. You will still get bonus points, extra credit for answering. All right, so this one says I have 2 integers, and we know what an integer is, right? We discussed integers in section 2. Integers are just whole numbers.
Wait,
represented.
Can I take a guess, like right now?
Yeah, take a guess right now, in positive or negative.
Let's see. I think it's gonna be number A.
Letter A? Okay.
Yeah.
Okay. Let's see. So I know that I have 2 integers. I have another fancy buzzword. The 2 integers meaning whole numbers, either positive or negative. The sum, meaning when I add up the 2 integers, they will be equal to -12. All right, so negative 12, my two integers. The sum means I'm going to add, right? Add up the two numbers and they should equal negative 12. And the product of those two numbers is going to be 27. So I have another two clues actually, because I have products. So that means I know I'm going to be multiplying multiplying the two numbers to get 27. If I look here, I see that it's going to be a positive 27. If I look at my rules, right, if I add two numbers together and I get a negative value, that means I'm going to be adding two negative numbers, right? And I also know that if I multiply two negative numbers, it should be positive. So that lets the rule still work, right? If I have two negative numbers and my sum is negative, and then if I have a product of two negative numbers, the product will be a positive value. So we can start plugging in numbers. So Brody guessed that it's going to be A. If I add negative
I know what
2
it is now.
plus negative 6, I know that I can add those absolute values together and move over my negative sign because I am adding value to the negative side or to the left. So that's going to be negative 8. So negative 8 doesn't allow the sum to be negative 12 in our equation or in our word problem to be true. So that's not the answer. All right, if we look at B, let's skip B for a second. Let's look at C. I have two positive numbers, right? I have 4 and 3. So it couldn't possibly be equal if I add those two to negative 12. I have 3 and 9, but those are positive. So that again is not going to be equal to negative 12 because this is equal to positive 12 when I find the sum. So we'll go back to B. It's the only one left. So process of elimination is going to tell us it's probably B. But let's just do the math just to make sure. Maybe I'm wrong. I have negative 3. I add negative 9. Right? So that means I'm going to be adding to the negative value. So 3 plus 9 equals 12. So that's going to give me negative 12. So that means that this holds true. Negative 3 plus negative 9 does equal negative 12. If I have negative 3 and I multiply it by negative 9, 9 times 3 is 27. And according to my same sign rule, if I multiply two negatives, that will give me a positive. So our answer to our super fun math puzzle is, is going to be B. Brody, it's okay to guess the whole alphabet before you get it right. No worries. You try to destroy the math. All right, that's okay. So the answer is B. That was a hard problem. There's like two steps. All right, so next, which two integers have a sum, right? We're doing the same thing as last time. We have a sum, meaning we're going to do what? Add or subtract? Jose, you were close. Okay, so my two integers, am I going to be adding? Oh, I already put the plus sign, sorry. All right, so sum means I'm going to add two integers together, and that will equal negative 21. Okay, so that gives me a clue, right? If the sum of two numbers is negative 21, should my values be positive or negative? Yay, Jose, yes, sum does equal add. Perfect. Got your bonus points. Same with Brody. Okay. So if I am adding two numbers and it gives me a negative value, will my two numbers be positive or negative? Okay, negative. So I know that I should have two negative values here. Let's move on. I have a product, and I'm going to multiply the two numbers together. And the product is going to be 108. And if I look at 108, there's no negative sign, so I can automatically assume it's going to be positive, right? And if I am multiplying two negatives together, it will give me a positive. So this allows both parts to be true. I know I'm looking for an answer that has two negatives. You think it's B? All right, so if I add, we can start with B. If I add 10, positive 10, and I add 8, that's gonna give me a positive 18. But I need my sum to be negative 21, right? And I only have one answer that has two negative numbers. So let's try that next, right? Because we know that 10 and 8 doesn't work, right? Because it equals positive 18 when I add those together. So if I add negative 12 plus negative 9, that tells me that I'm going to add 12 and 9 together, but it will be negative, right? So I added value to the negative side. So negative 12 plus negative 9 is equal to negative 21. It is a devil in disguise, sorry. So yep, that means you're close. So I have right here, negative 12, negative 9. This is going to be true. Negative 12 and negative 9 does equal negative 21, right? And now, let's see, negative 12 times negative 9. If I multiply two negative numbers, that will give me a positive value. So 12 times 9 is equal to 108. Right, because here's 18. 9 times 1 is 9 plus 1 equals 10, so 1008, right? And it's going to be positive because we multiplied two negatives. So our answer is not A or B, it is D. A is very close, right? But we needed the sum to be negative 21. Does that make sense, you guys? I mean, I know we can vote that it's a positive, but it's going to be negative. And you were very close, Jose. I like your positive attitude. But we have to make sure that we understand that we have two negative numbers because the sum is negative 21. You can't add two positive numbers together and get a negative value. Okay, you guys have questions on that guided practice? Hey, he's not out. Unless it was just two, I think. Unless he got A wrong. I think, no, he got A right. Or like number 1 right. So it's like 2 strikes.
It is free because I said it was going to be A, that's 1. Jose said it was going, well, no, wait. I said it was going to be
That means you have 3
B.
strikes too. You have 3 strikes too then. Nobody's out.
No. I said B, that was 1. Jose said it was A, that's 2. I said it was A, so that's free.
I think you guys are all the best. And I don't want anyone to be out. All right, so we're done with the guided practice for section A. All right, 9. So now we're gonna move on to roll 9. Okay. So now we're gonna be multiplying rational numbers with different signs. So multiplying, right? We're gonna have value. We're gonna multiply another value, right? So our expression or equation would look something like this. X All right. Okay, so we just got done multiplying rational numbers with the same sign. So we had the same sign rule. But now we're going to be doing the different sign rule. Okay, so that will look like positive times a negative. And if I have a positive and I multiply it by a negative, it's going to always be negative. I'm going to take that as a compliment. I like being super nerdy. Okay. So then another way that multiplying rational numbers by different signs, it could look like negative times a positive. And that's going to always be negative, right? Because these are the same. It's like flip-flop.
I was gonna say a positive.
Were you?
Yes, because you switched them up.
Yeah, I could see that. But if we look at it, right, I have a positive times a negative and then a negative times a positive. We should be able to, like, if I have, when I'm multiplying, I should be able to put the numbers kind of like in whatever order and it still come out to be somewhat the same as long as it's like the same multiplication across. Plus, it's a different signs rule. And so we know it's going to kind of be opposite of our same signs rule. Okay, so if I have two positives, it's going to give me a positive. If I have two negatives, it'll give me a positive. If I mix it up, if I have a positive and a negative, it's going to always give me a negative. And I'm multiplying. Okay. All right, so we're going to do a little bit of a practice here on our section 9. Where did I put that? Okay. All right, so step 1, say if I am using a number line, which I know that it's not likely to always use a number line, but as we're learning these kind of new concepts, sometimes it's easier to visualize these when we can see it on a number line. So we're going to start at 0. I'll use my highlighter, easier to read. And I'm going to solve I guess there's no problem there, huh? I'm going to solve 3.5, negative 3.5 times negative 2. Sorry, that's going to be positive 2. Okay, so I'm going to start at 0. I'm going to move over negative 3.5 2 times. I see here that each section is divided into 2, right? Each whole value is divided into 2 spots. So that means that my little lines are worth a half. 1/2 is equal to this, or is the same as 0.5. We know that by now. We've done that quite a few times. So in order to go back, counting negative 3.5 2 times, right? Here's 3.5 once. And I'm going to go over 3.5 again. Here's 1, 2, 1, 2, 3.5. Okay, now I need to read my number line. I'm here at negative 7, right? But my rule, right? I need to check my rule. If I have a negative and I multiply by positive, right? So I went negative 3.5 2 times, positive 2 times, right? 3.5, 3.5. My answer is going to be negative right? And so what my negative 3.5 times positive 2 gave me negative 7, right? So that made my rule true, right? Because I had negative 3.5. I multiplied by positive 2. My answer was negative 7. Right, so I had negative, positive, equal to negative. Okay. Is that making sense?
Calculating.
There isn't that much to write so far. All right, so we're going to solve.
Seems like it.
We had ones where we had to write way more. All right, so now we're going to solve for positive 0.56 times negative 8. Okay, so I have 8 times 6. 8 times 6 is going to be 8, 16, 24, 32, 40, 48, 54. Okay, the 5. 8 times 5, that's 40. No, I just lied. 8 times 6 is 48. 8 times 5, that's 40. Plus 4, that's 44. Carry the 4. 8 times 0 is 0. Then I add that 4. Okay, and then I have a negative, right? Technically, I have a positive, right? Times a negative. That's going to give me a negative, according to my rule. So I have negative 4.48. Okay, so I'm going to have negative 4.48. Remember, if I have a decimal place, two numbers, I need to make sure that I have two numbers is my answer for the decimal place. So far. There's a little bit more writing coming up, yes. All right, so we're gonna, but look, it's not bad. It's not bad, right? So now we're gonna solve for negative 2.6, right? Negative times a positive. It's going to give me a negative answer. So I know that it's going to be negative. So I can put my negative sign there now. I don't forget it. Okay, so I have negative 2.6. I'm going to multiply that by positive 3. Okay. So 3 times 6, that's 18. Okay, the 1. Then 3 times 2, that's 6 plus that 1. So I have 7.8. I know that then I have one decimal, right? One decimal place here. That means I drop my decimal point right here. And we have one number after. So my answer is negative 7.8. I just simply multiply these two numbers, and I know that the answer is going to be negative, right? Because my rule. I don't have to do anything fancy. I just need to know that my answer will be negative, right? Jose, that is not positive thinking. Okay, so multiplying more than two rational numbers. Okay. Ready? This is a fun one. You guys are making me laugh. All right, so this is going to be fun. Ready? So I have negative 1/2. All right, and then I may need to multiply. I'm going to show you guys how to do it easier, okay? I need to multiply negative 2/3. And then I need to multiply negative 3/5. But I'm just gonna do 2. I don't need to do it all at one time, right? Okay, so let's look at it. Small chunks. I am multiplying two negative numbers, right? That means I go back to my other rule. I have my same sign rule. I'm multiplying two negatives, so I'm going to get a positive. -1 times -2 is equal to 2. That's me positive 2, right? And then my denominator, 2 times 3 equals 6. So I'm going to have a positive 2, 6 so far. So yes, you can make it through the entire math course. Thank you. Okay, so now I need to take that 2, 6, and I need to multiply it by this negative 3/5. Okay, so 2, 6 times negative 3/5 equal. Now I am here in section 9. I'm going to be multiplying a positive, right? Because I have positive 2, 6 times negative 3/5. So I know that my answer will be negative. I'm just going to carry that negative sign over it now. 2 times 3 equals 6. Right, so I have negative 6 over, and then I have 6 times 5 gives me 30. So I have negative 6 over 30 is my answer. I can simplify that, right? Let me look at my common factors. I have 6, 5, right, for 30, 10, and 3. I could actually divide 6 by 3, and I could divide 6 by 6. If I divide 6 by 6 and 30 by 6, that also gives me, is my simplified fraction, -1 over 5, right? So my answer is, and I'll take either one when it comes to this right now. You don't always have to give me this simplified fraction, but it's -6 over 30, or is an equivalent fraction that is equal to -1/5. See how much easier that is than going and looking across, like see how I have 3 numbers here. You can split it into chunks. Yeah? All right, so we have 12 minutes left. I feel like you guys are gonna kill it. Ready? We have our guided practice.
We get to kill it?
Yeah. I'm so proud of you guys.
Knife.
Maybe don't do that, but I just mean like do really good. Like be really smart. Be math nerds. Like me. It's fun. So much fun.
Oh my lord, all the words.
Yes, there's a lot of words.
Why are we doing a chapter book?
There's 2 sentences. You actually technically
So
like
far
read
away.
more when you were doing your bookets. Okay. I'll read it to you. I'll read you the first one. Ready? You don't even have to read this one. Eric's grandmother is making her famous chocolate chip cookies. She has, remember, I like to always highlight the numbers, right? Because I want to know what I'm working with. So she has, this tells me she has it, right? That's something she has to go get. She has 10 cups of chocolate chips in her pantry. And each batch of cookies needs 1 3/4 cups of chocolate chips. After making 3 batches cookies, how many cups of chocolate chips does Eric's grandmother have left? Ooh, this is a doozy, right? All right, Eric's grandmother's making her famous chocolate chip cookies. So she has 10 cups. That's how many we have? 10 cups. Then for each batch of cookies, she needs 1 3/4 cups of chocolate chips. Okay. So that means per batch of cookies, we need 1 3/4 cups of cookies. So we can think of this as 1 3/4 cups over one batch. Kind of like when we see a speed limit sign, we see 60 miles, right? Over 1 hour, right? Our ratios. Okay. And now we know that she's made 3 batches of cookies. All right. And then it says how many chocolate chips does she have left? So we're going to section this. First, we're going to find out how many she used.
Quick question.
Quick answer.
Okay. Is she like Homer or is she like the average girl?
Homer? I don't know. All right.
Because
So
it says
I
Homer,
have.
it's 0.
That's funny. I get it now. All right. So 1 is equal to 4 over 4, right? If I have 4 over 4 and I need to add my 3/4 of a cup, so it's easier for me to work in just having a whole fraction, right? So I'm going to add 4 plus 3 because my denominators are the same. I have 7 1/4 cups per batch. Okay. And then I know that she has made 3 batches so far. Right?
Joseph says that his guess is number B.
B. Okay, we'll see. So I have 7 1/4. Then I need to multiply by 3. Right, so I'm multiplying by 2 positive numbers, right? Because I don't use negative amount of chocolate chips, right? And she made a positive 3 batches. So I have positive 7/4 times positive 3. So I know that my answer is going to be positive, right? And I can think of 3 as a ratio of 3 over 1. So 7 times 3 equals 21. And 4 times 1 is 4, right? So I have 21 1/4 cups, 21 1/4 cups that have been used, right? These have been used up. So she had 10 cups to start off with. So if I started with 10 cups, and I can turn this into a fraction over 4, right? I want it to be equal, instead of 1, I want it to be a value over 4, right? So 10 times 4, that's 40. 1 times 4, that's 4. So let's see, I have 40 over 4. And since I used 21 over 4 cups so far, I'm going to subtract it from what I have or what I had, right? Because I used these, they're gone now. So I need to subtract them from my total, 21 over 4. So I am going to subtract 40, subtract 21, that's going to give me 19. 19 over 4. Does that make sense, you guys? Because I need to find out how many I have left, not how many she used. How many I have left. So this is a multiple step question. All right, so I have a mixed number, right? Because 19 over 4 is a mixed number, right? I have all these whole numbers in front of a fraction. So let's see, let's do 19 divided by 4 and see what the remainder is. So 4 goes into 19. I have 4, 8, 12, 16, 20. Oh, too far. So here's 4 is my whole number. 4 times 4 is 16. So my leftover is 3. So I have a remainder of 3/4. So do you guys see on here? I have 4 3/4. The answer is C. Because I have 4 3/4 cups left of chocolate chips. Does that make sense to everybody? It makes sense? Woo! Perfect. All right. So we have 5 more minutes. So we'll do number 2. And then whatever's left over, you guys can do on your own for homework, but I think we'll only have 1 left over. If that. I can go pretty fast, right? It's like only a little bit of writing. All right, so Callie loves her antique clock, but is disappointed when she discovers that it has lost 5.5 minutes in 1 week. All right, so it lost 5.5 minutes. We know that lost means negative, right? Because it's taken away. It is broken.
Plus,
That
why
means
would
the clock
somebody
is,
still want it to paint in numbers?
well, it means that the revolutions are not going at the pace of time, right? Because it has to be a ratio, right? Every minute it clicks, it goes by a speed divided by a time or a distance.
Oh
Anyway.
no.
Hold on. She then discovered the same thing happens for an additional 6 weeks. In 7 weeks, how much total time has the clock lost? And this means that the clock is moving too slow, right? That means that when she looks at the clock, right, it's not giving her the right time. It's 5.5 minutes slow. Okay, so Callie loves her antique clock. It has lost 5.5 minutes. So I have negative 5.5 in 1 week, right? That's 1 week. So every week it loses 5.5 minutes. And she discovers this happens for an additional 6 weeks, right? So we have 5.5 minutes over 1 week. So our answer, what we want to find out is how many minutes have we lost in 7 weeks, right? So let's see. Let's figure out, I have 7. I need to multiply this by 7, right? Because I want to get to 7 weeks. Okay, so 7 times 5.5. I know this is positive, right? Because I'm not going back in time weeks. I'm going forward in times because it's over 7 weeks. So 5.5 times 7 was like, okay. So that means I have 38.5. I know because I have positive and I multiplied by a negative. That's going to give me a negative number. I have negative 38.5 or negative 38.5 over 7 weeks, right? So in 7 weeks, I lost 38.5 minutes. And since it asks me in the question, how much time had the clock lost, right? If it lost time, I don't need to answer in negative terms, right? Because the question already indicates that it's going to be negative. The thing, it lost how much time. So it lost 38.5 minutes in 7 weeks. It's simply just multiplying 5.5 by 7, right? Because we knew each week it was going to lose 5.5 minutes. Like if we look at it as like here's week 1, right? Week 2, week 3, week 4, week 5, week 6, week 7. If I lost 5.5 here, lost 5.5 here, lost 5.5. Here's 3 weeks. Here's a 4th week, 5th week, 6th week, and then 7th week. I can just add that all up, right? Because I know in that week span of time, I lost 5.5 minutes. And so it is increased and lost 7 for 7 weeks. All right, so you could even just add these up too. Does that make sense? You know, the word problems can be hard, but we're in middle school. You guys are about to be in 8th grade, so we got to be able to understand the ratios. This is what was supposed to be like the most important thing that you learned in 7th grade.
Online.
It is 10 times harder to be online. I agree, Brody. And you guys got stuck with Edgenuity for most of your 7th grade. year, but that's okay. We made up for it. You guys get it now, right? It does, yes, right, Jose? At first it kind of like looks crazy, but just a little bit of practice makes it make sense. All right, so it is 1:20, so I'm going to let you guys go. For homework, your homework is do question number 3. That's it. Okay. If you guys finish that Nearpod, I am going to post videos for the verbiage on 10, 11, and I think 12. So that way, if you guys watch the videos and fill that in correctly and then do the guided practice, I'll give you guys, it was like 12 points of extra credit, and that can give you a whole letter grade bump. Okay. So if you guys finish that up, you will get extra credit. Okay. And you guys are ahead of everyone else. So that should be a benefit to you guys. Bye, Christian. Bye, Ella. Bye, Damien. Thank you guys so much for participating. You guys are amazing. And thank you for letting us be ahead of everyone else. I'm competitive, even when it comes to myself. All right. Bye, everyone. Have a good rest of the day. Thank you, guys. And our last week of school, all minimum days. If you guys have any questions on makeup work, feel free to message me. I am getting a lot of messages, so bear with me. If you need to message me 2, 3 times, you can. Don't feel bad. Sometimes I look at it and then I think I'm going to send something and then I forget. I'm human. It happens. But if you want missing work, please don't hesitate to reach out. Again, all of the assignments are in Teams. If you're looking at Teams and it says you have no assignments, check the returned section, because when I grade, I put 0 in and return it to you as like a little reminder, like you did not finish this assignment, so do it. I know, so mean. All right, thanks guys. Have a good day. Bye, Kailash. Bye, Sienna.